towards its end position. So star, see the arrow, all hydrogen nuclei get fused. Then a star expands. Then we have two types of options, red giant, red supergiant. So last
Supernova
time,
and planetary nebula.
this is the end process of a star. This is how a star begin to die, so-called die. So can you recall for me this process now? I have explained it again. And can you recall for me?
Which one? I didn't understand which progress will you call.
Uh, this whole sheet, this whole process,
Okay.
you can look
First of,
on this.
first of all, is the star when the star it's the time ending process time, and then the all the hydrogen nuclei will get fused. The star gets expanding, it gets bigger and bigger. When it's more like the most massive, it will be red supergiant, and when
Hmm.
it's the less massive, it will be red giant. Then from red supergiant, it is supernova, and then when it explodes, it becomes nebula or neutron star, or it can be a black hole too. If it's less massive, then red giant, then planetary nebula, and then it will become a dwarf planet.
Okay. What is a neutron star? I have shared you some videos. Did you try to view them?
Yes, sir, one of them only.
Hmm.
So you shared this me in the morning, right?
Sorry,
So when did you share me these videos in the morning?
I think so. You can check on your WhatsApp. I don't remember the time, but what is a neutron star? Now connect from here.
Neutron star is the collapsed core of a massive supergiant star.
Neutron star is a mega object, and this is just like the mega players in our universe. If you haven't seen those videos, you should view them because space and cosmology, I'm sorry, because space technology, space and cosmology is a very high level topic. So we need some animations, videos, and obviously in our class, there's always a limited space. So neutron star is the collapsed core of a massive supergiant star. So can you look from here now that when the star is expanding, normal stars become a red giant, but a massive star becomes a red supergiant. Okay, this was neutron star. Acha, what is a black hole? Black hole is a very big discussion. A lot of people have talked about it. It's a very favorite topic in science fiction movies. And black hole is actually a dead star in our rough language. it is so dense, the black hole is so dense that nothing can escape. Even light cannot escape from it. And it is one of the mysterious objects in our knowledge. Neutron star is much more mysterious, but still we have not studied much about it. But humans have studied black holes. Black hole is so mysterious. Why? Because you can't take a picture of it in normal regular sense, because it absorbs everything. When you take a picture of anything, like you take a picture of yourself, you actually go for reflection. When it doesn't reflect any ray, you can't take a picture of it. The nebula from a supernova may form new stars with orbiting planets. Now, look at this very simplified version. Massive star, which much larger than our sun, red
So this is a past
supergiant.
paper question.
Hmm?
This is a past paper question.
This is a past paper question, but a part of it. Massive star, much larger than sun, red supergiant. Okay, then supernova. Supernova can convert into a neutron star and a nebula. Actually, nebula is a term used for a very basic version of components. So nebula from a supernova may form new stars with orbiting planets. Now you have to copy this. Remember, we are talking about the end cycle of a star. It's a death protocol for a star. A star is now going off. When it's a massive star which is now going to die, it first becomes a red supergiant. Red supergiant becomes supernova. Supernova can break into a nebula and a neutron star. There is an option. Sometime instead of neutron star, a black hole comes.
So should I copy this?
I think I told you to copy it. You didn't copy it.
No.
I told you to copy it.
Okay, okay, I'll copy it, Friday. Okay, I'll copy it. Okay, done. Done.
Okay. Let me share the bigger version which you have to learn. So there is an extended version. This one. This summarizes the whole process. Now you have to write, because it will take a lot of time to copy. So I'm sharing it with you, but you have to copy one of them, at least one of them in your notes, because obviously posters are not very remindable. So I have shared it with you. Now, please give us side heading summary. Okay, but I'm starting now. This is some of my students told me that when you share a poster, after some time, it's very difficult to find the relevance in the notes. And if I ask people to copy, that will take an much extra time. So now I'm starting a concept that I am putting a reference number on my WhatsApp chat, and I will ask the student to write it in your notes also. Now, in this way, what will happen that if you, after the class, maybe after a month, if you want to see what is the left space here, maybe you couldn't copy, or maybe you copy and there is an error in the copy. So this will be a reference here. Okay. So now you have to give a side heading summary and write under it reference number 1.
But sir, after 1 month or like 2 months, the file automatically goes off.
But images, I think images are there. File can be there, but I think images survive.
I'm not sure about that, but
Files
sometimes
are like PDF may have an expiry, but I teach regularly, na, so I see images are there. If you have if you have a auto delete option on or something like that. Otherwise, WhatsApp images I think can survive easily for the whole session. That happens with some images when you press it and he says tell the sender to send it again. That happens when there is a memory limit and you have stopped it. Otherwise, I have seen that they are there. But anyways, it's your choice. You can shift it to normally, even if they go from here, I think in the gallery you can find it. But personally, I think that you can shift it to any, because these posters are very helpful. Nebula, protostar, main sequence, red giant, red supergiant. Red giant becomes white dwarf, which later can become black dwarf. Red supergiant becomes supernova, which converts into a neutron star or a black hole. Now you have to give a heading, a very fascinating picture, the universe.
okay.
Now, this is a fascinating topic. A lot of movies have been made and a lot of things are now in discussion. Latest after the launch of the new, very advanced James Webb, now a lot of new knowledge is coming up, and scientists believe that it will be a new chapter, a new horizon they are going to get. Universe is a word which is now in a very big scale. The Milky Way is one of many billion of galaxies making up the universe, and that the diameter of the Milky Way is approximately 100,000 light years. So you can imagine, if the Milky Way is so big that light takes 100,000 light year. So billions of galaxies will make up the universe. So how much big is the universe? So this is something which goes beyond imagination, that can we reach the end of the Milky Way? No, it's not possible right now. Obviously, when light takes 100,000 years, then obviously we cannot go like that. But Milky Way is one of many billions of galaxies. And this number is counting. Even our syllabus is a bit old. And I was reading latest that now these galaxies are huge. Milky Way is one of the billions of galaxies. So you have to copy this, our syllabus reference number. Syllabus
So
screen.
what if we write the latest reference number? They'll mark it as
No,
wrong.
no, no, you can't do that. Otherwise, I would also have taken it. Na? It's a rule in our course. You cannot go for anything which is in the news, which is in the social media, or which is in a paper, even a science paper on a NASA website. No, you have to follow the syllabus. So if you see my notes, and once you have a chance of looking at the syllabus, you will see that I always try to strictly follow the syllabus, even the numbers.
What if that the theory that was proved like a long back, it's wrong now, and the syllabus is teaching the same thing?
Then you have to follow the wrong one. Even though I think they update now very frequently. Now they update now to 2022 was the update. Now they are getting ready to update again in 2024. Now, with the pressure of the innovations and new research, our boards are getting also very active. Now they are updating the syllabus very often. So now Hamad, read this concept and you have to try to feel the size because they want people to feel the size. The Milky Way is one of the many billions of galaxies, and the diameter of the Milky Way is so big that it takes 100,000 light years, and light travels so fast that it takes only 8 minutes to reach from the sun to the earth. Now, Milky Way is so big, and Milky Way is part of galaxies, and there are billions of galaxies. So have you copied it? Let me know once you have copied it. Hamad, can you hear me?
Yes, sir. 1 minute. I'm just writing, finishing what.
Okay, have you?
One. Okay.
Now, you have to give a new heading, red shift. This is another mysteries, and this is one of the mysteries of earlier time when humans start navigating space, and when humans were on the earth, they were able to see this feature that some objects appear to be red. Some objects appear to be red, and after some time they disappear and they appear to be red. They call it red shift. Now it was initially a very big mystery that why some things are appearing red. Red shift is actually called Doppler effect. Doppler effect is what? Doppler effect is a visual or apparent change in wavelength. For example, you are standing on a road and an ambulance is coming towards you with a siren, you will feel the change in the frequency of the siren, even though in real, the siren frequency is not changing. But on observational level, only in an observation level, the frequency is changing. When the ambulance crosses you, the frequency now begin to change again. So scientists thought about this observation, and this is called in physics as Doppler effect. What is Doppler effect? When something is moving with a frequency towards you, you will feel that its frequency is increasing. So for example, this is a siren car, like for example, it has a siren on it and it is generating siren frequency. This thing is moving and you are standing here. Now, When it is coming close to you, you will feel that the frequency will increase. When the vehicle crosses you and it goes away, then you will feel that frequency decreases. This is an apparent change. In reality, nothing is changing. When you are standing somewhere, if you have a chance, a train crosses you. When a train crosses you, you will feel that frequency will increase when the train approaches you. But when the train passes by you, frequency apparently decreases. This is actually a concept which we refer here. This is actually a concept of Doppler effect. This phenomena also occurs in our light vision. We have a vision of 7 colors with Gaia. When you move from violet to red in electromagnetic waves, frequency decreases. And when you move from, you can see here, violet to red, frequency decreases and wavelength increases. These are the 7 colors. Now, what happens that when when a light source is moving away from you like a star is a light source. When a light source is moving away from you, its color frequency apparently decreases. Now, when frequency decreases, the rule says the color apparently shift towards the red because red is a low frequency. So color appear to be reddish. So when something is moving away from you in a universe, because universe is so big, it can move away. When something with a light like a star, when a star is moving away from you, its light apparently become red because as it is moving away, its frequency decreases. So from vision point of view, you will see these red, these red stars, which are actually not red, but they are moving away from us. So as they move away from us, what happens that their light coming to us shift to red. This is called a Doppler effect. This is called Doppler effect, and this phenomena is called red shift. So after giving the heading, you have to copy this. Let me know once you have copied it.
Okay, sir, done copying.
Okay. Right under it, that red shift is an application of Doppler effect. You have to copy this. Doppler effect means apparent change in frequency. Now, look at this screen and you have to copy this now.
Okay, sir, done.
Now, what happens when a source of light, like a star, when a source of light from a star, like a star, is moving away from our planet, it will appear to be red. Actually, it is not red, but its light apparently begins to red because actually the color frequency shifts towards red. Color frequency decreases. When frequency of color decreases, the color apparently moves towards red. This phenomena is called redshift. So you have to copy this.
Okay, sir, done.
Hmm. Have you copied it?
Yes.
So this is called redshift. Now, what is the why this is such a big discovery? It should be remembered that when something appears to be red in a space, it means it is going away from you. I repeat my concept. It's a very technical concept. If you are traveling in a space and you see a star which is getting red, it means the star is going away from you. So when scientists discovered this red shift, they got very amazed because it means that all the stars are going away from us. None of them were having a blue shift, all of them were having red shift. Red shift means that the galaxies, the stars, everyone is going away from the Earth. Why this is so important? It means that our galaxy, our universe is actually expanding. Our universe our universe is expanding. So this lead to be a very famous unmatchable theory, which is called Big Bang theory. So now we move to our next concept. You have to copy this. Let me know once you have copied it.
1 minute. I'm just writing it.
Okay.
Okay, sir, done.
Okay, Ahmad. Now can you repeat for me what is redshift?
The light, wait. Oh, redshift is an increase in the observed wavelength. Uh, it is increase in wavelength and decrease in frequency.
When something is moving away from us. This is redshift. Now, can you tell me from this diagram, look at this photograph. Can you see many red spot here?
Yeah,
Yes, Ahmad.
yes, I can see.
So what does this mean? That these stars which are looking red, are they going towards us or are they moving away from us?
They are moving away from us.
Yes, this is the main concept. You have to understand this main concept. In a space, if something appears to be red, it means it is moving away from us. Do you see some blue stars?
Yes.
It means they are moving towards us. Redshift means the star is moving away from us. Can you repeat what the redshift means?
The stars are moving away from us. So is there
And
something blue shift?
majority stars are redshift. Huh?
So is there something known as blue shift or no?
Blue shift is only a virtual thing. Now scientists believe it exists and they have shown it in this picture also. But actual thing is redshift. Majority stars are on redshift. What redshift means? That these stars are moving. These stars are moving away from us. Now look at this. Star is going away from you, redshift. Star is coming towards you, then what it is? Look
Blue
at this
shift.
diagram. Star is going away from you. What it means? Redshift. And a star is coming towards you. What it means?
Blue shift.
Blue shift. Now, the light emitted from distant galaxies appear redshifted in comparison with light emitted on the Earth. It means all stars, majority stars are going away from us, which means galaxy galaxies are galaxies are moving away. The universe is expanding. Now you have to give this heading, the Big Bang Theory. This is a topic which also being a discussion, and this is another very famous topic, one of the biggest theories of present time. Give the heading, the Big Bang Theory. Hamad, have you copied it?
Just a second, there's a missed call. Okay, sir, I'll give the heading Big Bang.
Okay. What is the outcome of redshift? Redshift means all stars are moving away from us. It is just like on a road you are moving and all the vehicles are going away from you. So scientists concluded that it means that everything is going away from us. So there must be an expansion, because when something is going away from us, it means universe is expanding. So I repeat my concept. Redshift is an evidence that universe is expanding. What's the concept? Redshift is an evidence that universe is expanding. I want you to again look at this picture. Look at this picture. These red star means that these stars are going away from us. And it means that our universe is expanding. Our universe is expanding. This is the basis of a famous theory which is called Big Bang. So Big Bang theory says that universe began just as a single point. It was a single nebula, a single point from where there was a big blast and then expanded and stretched to grow as large as it is now. And it is still stretching. So it means it's like a balloon. When you inflate a balloon, balloon expands, stretch out. So Big Bang is a theory which says that our universe was a single point and then it got an explosion, unexplainable right now, but there was an explosion. Due to the explosion, the mass, some of the energy converts into mass, and these mass particles are moving away from each other. So we have a universe which is expanding, which is moving away from the central point. So now you have to copy the second paragraph only.
Okay.
Yes, Hamad, have you copied it?
Yes, sir. Complete.
This is called Big Bang Theory, and the theory says that it was a center, one point, there was no universe. That one point exploded, and from that one point, energy converts to mass. These all particles came up, the planets, the stars, comets, whatever was there, and they all move away, just like an explosion. Things go away. They all go away, and still they are going away. Just like a blast is still there, and universe is still stretching. You have to see this thing. This is how we show. Look at this. There was nothing in the start, just a nebula. Now, this is called Big Bang.
Up until the 1920s, everyone thought the universe was essentially static and unchanging in time. Then it was discovered that the universe was expanding. Distant galaxies were moving away from us. This meant they must have been closer together in the past. If we extrapolate back, we find they must have all been on top of each other about 15 billion years ago. This was the Big Bang, the beginning of the universe. But was there anything before the Big Bang? We used to think that the theory of the universe could be divided into two parts. First, there were the laws like Maxwell's equations and general relativity that determine the evolution of the universe, given its state over all space at one time. And second, there was the question of the initial state of the universe. We had made good progress on the first part, and now have the knowledge of the laws of evolution in all but the most extreme conditions, but until recently, we have had little idea about the initial conditions for the universe. However, this division into laws of evolution and initial conditions depends on time and space being separate and distinct. Under extreme conditions, general relativity and quantum theory allow time to behave like another dimension of space. This removes the distinction between time and space, and means the laws of evolution can also determine the initial state. The universe can spontaneously create itself out of nothing. Moreover, we can calculate the probabilities that the universe is created in different states. These predictions are in excellent agreement with observations by the WMAP satellite of the cosmic microwave background, which is an imprint of the very early universe. We think we have solved the mystery of creation. Maybe we should patent the...
Now, this is the Big Bang Theory, and this animation shows that it started with a single point and exploded. Redshift in the light from distant galaxies is evidence that the universe is expanding and supports the Big Bang Theory supplement. Redshift provides evidence for the Big Bang Theory. Now you have to you have to copy this. Hamad, can you hear me? Hello.
Yes, sir. I'm writing this one. Okay, done.
So redshift is an evidence that universe is expanding. Redshift is an evidence the universe is expanding. So to write under it, redshift is an evidence that universe is expanding. So you have to copy this. Redshift is an evidence that universe is expanding. So this was the first proof. Later, the Big Bang Theory also came up, and Big Bang Theory verified, or you can say Redshift verified the Big Bang Theory. Now give the heading, Cosmic Microwave Background Radiation, CMBR. You have to copy this.
So this is an important topic.
No, this Big Bang is a part of the syllabus, but much top is not a topic of this level. Big Bang is a very big topic. So definition is there, concept is, redshift is important. Cosmic microwave background radiation, CMBR. Now, what are these? microwave radiation of a specific frequency is observed on all points in space around us and is known as cosmic microwave background radiation. So I hope you remember this word background radiation that was in nuclear physics also. So they have noticed that around our planet, they find microwave signals of the same frequency, which shows that there is a blast. Because whenever there is a blast, there is an explosion, you will find some frequency there, microwave, sound waves, and other waves. So even if you close a door strongly, the waves are produced. So microwaves are around us and they are called the CMBR. You have to copy this definition.
Certain.
Okay. Now, Hamad, what is Big Bang Theory? What is you can see the notes you have copied. So what is the Big Bang Theory?
Big Bang.
You can look
Big
at
Bang.
the notes.
Yes, sir, I'm looking at the notes. 1 minute. It is just like it is a physical theory that describes the expanding of the universe.
It's a theory which says that
And
the
the universe
universe was
is
originally a single point. There was nothing, and it explodes, and then all the things came out of it. It's an explosion which is still continuing. So can you repeat what's Big Bang Theory?
Big Bang theory is a theory which tells that uh, it which tells that
Hmm.
that universe from a single point it blasted, and then now it's until now it's expanding.
Expanding. It's an expansion. So it means if you repeat the concept with me, Big Bang Theory says that the universe was nothing. It was a single point. It exploded, and now it is expanding.
Mm. Big Bang theory says that universe was a single point, it exploded, and until now it is expanding.
Yes. And redshift is the fundamental evidence. Redshift, acha, what is redshift?
Fundamental evidence.
What is redshift? If you need to define redshift,
Redshift is when the star is moving away from you.
moving from away from us, it appears to be what?
Red.
Red. Very good. So when a star is moving away from us, when a star is moving away from us, its color apparently becomes red. And this apparent change is called redshift. Now, Hamad, can you repeat? What is the what is the Big Bang theory again?
Big Bang theory is that the universe was at a single point, it exploded, and it is till now it is expanding.
Yes. Now look at this temperature difference from average, and this is called CBM, and this is a signature. This is a microwave signature. Now, what the microwave signature is telling us, actually, whenever a blast occurs, there is a signature. When you run a microwave oven, when you make a call, when you receive a signal, there is always a signal signature. There is always a signal signature, like you are receiving WhatsApp and messaging. So you hear a beep. This beep is a signature. We call it a signature of a wave, maybe microwave, maybe infrared wave. So similar to that, in our universe, scientists have discovered that there is a microwave signal signature all around us. This signal justifies that there was a blast here, and this blast result is still undergone. It is still going on. So we keep it up to here. This topic is now nearly finished, but we have to do it, inshallah, in our next class. Thank you. Happy New Year. Allah Hafiz.
Allah Hafiz.